In this section, we'll look at what we mean by a theoretical probability, and in particular, look at some formal definitions of probability and vocabulary that goes with probability theory. The probability of an event occurring is the likelihood or chance of that event occurring. Now you can express that likelihood or that chance, that probability, as either a fraction, a decimal, or a percent. An event that is certain to occur has a probability of 100%. An event that cannot occur has a probability of 0%. There are three common types of probabilities that can be calculated or discussed. Empirical probabilities are probabilities based on observations or experiments, or basically on data. So we dealt with empirical probabilities when we looked at contingency tables because we were looking at data. Theoretical probabilities are probabilities based on the assumption that all outcomes are equally likely. This is often the case in games that involve cards, dice, or things where you roll something and every little option that can come up is equally likely. Subjective probabilities are probabilities that are estimated based on experience or intuition of the person who's stating that subjective probability. So here are three examples of probabilities. Let's kind of look at these definitions and determine the type of probability that's being described. Part A, the probability of rolling 2 dice and getting a sum of 11 is about 5.6%. So we've got a 5.6% chance of getting 11, and this is based on rolling 2 die. Now, I mentioned earlier that dice are often an example in a game of a theoretical probability, and that's because when you look at a single fair die, it's usually weighted in a way that you're equally likely to get any of those options coming up. So because things are equally likely to come up, this will be a theoretical probability. Next example, based on geological evidence, the probability of a major earthquake in Oregon over the next 50 years is 20%, about 20%. Notice it says based on geological evidence, so data. So this would be an empirical probability because it's based on data. And finally, I'm 90% sure that my friend will be late to lunch. This is probably something you might say based on what you know about your friend, that your friend is often late. And so you might throw out, I'm 90% sure she'll be late, or I'm 80% sure she'll be late. Now, if your friend is someone who's always on time, you might say, I'm 5% sure my friend will be late. That would be much lower. So this is a subjective probability, and it's often something that people will just throw out there in everyday conversation. They'll give a chance of something happening based on what they expect to happen. Let's look at some common vocab for probability. Now, a theoretical probability or probabilities are related to situations in which each outcome of an experiment has an equal chance of happening. Now, I mentioned the word outcome here in this definition of theoretical probability. What do I mean by an outcome? An outcome is the most basic possible result of some kind of experiment. An event is what we're going to describe the specific outcome we're interested in a particular problem. And then really important to outcomes as well as to calculating probabilities is what we refer to as the sample space. The sample space is the set of all possible outcomes. Let's look at 3 experiments and identify the sample space for each, which would be all of the outcomes for each. The first experiment would be to toss a coin. Now, many of you have probably tossed a coin before. There are 2 things that you're going to get. You're going to get a head or you're going to get a tail. So the sample space would be all possible things that could happen, and usually we write it as a set, so we use a brace. And I'm going to abbreviate head with an H and a tail with a T. And so my sample space would just be at H, T. Those 2 options are the things that can happen when I toss a coin. With rolling a 6-sided die, That would be like rolling a Yahtzee die. There are 6 numbers that can come up. They're all equally likely, 1, 2, 3, 4, 5, and 6. So my sample space would be those 6 options, 1, 2, 3, 4, 5, and finally 6. Now in the third experiment, let's say we are going to pull a marble from a bag that contains 6 red marbles and 2 blue marbles. What would the sample space be? Well, first off, when you pull a marble, it's either going to be red or it's going to be blue here, because all we have is red and blue marbles here. So you might initially think that your sample space would just be red, blue. But what we have to be careful about is there are 6 different red marbles. Those are individual marbles. So there are actually 6 different marbles that are red that could be chosen. And one way we could distinguish that is by numbering them. I could say R for red, sub 1 for the first red marble, R sub 2 for the second, R sub 3 for the third, R sub 4 for the fourth, R sub 5 for the fifth. I've got the fourth and the fifth. I don't know if I said that right. And then R sub 6 for the sixth. So I would have 6 red marbles that would be in my sample space, and I've distinguished them with subscripts. And then I've got 2 blue marbles. So I'm just going to do those the same way, blue 1 and blue 2. So my sample space actually has all 8 marbles in them, because technically when I draw a marble from that bag, my options are one of 8 different marbles. Even though they have the qualities of being red or blue, which are 2 different qualities, there are technically 8 possible marbles that I could pick from. So there are 8 possible outcomes, and that sample space has to include all 8. Let's look at a formal definition for calculating the probability of something. The probability of an event A, so that would be any event, let's just call it A, we can express as P of A is calculated by dividing the number of ways the event can occur by the total number of possible outcomes. So writing that as a formula, P of A would be equal to the number of ways event A can occur divided by the total number of possible outcomes. Now, those probabilities, when you get an answer, can be expressed in one of 3 ways: a simplified fraction, a decimal, or a percent. And it depends on what you're asked for in a particular problem. You may be asked for a fraction answer, a decimal answer, percent. The main thing is to read what you're being asked for. If it doesn't ask for one in particular, then it's your choice how you want to express those probabilities. All right, let's use an example that we just dealt with those marbles. We had a bag of 8 marbles, and 6 of them were red, and 2 of them were blue. If I wanted to use this bag of marbles and calculate the probability of finding a red marble using this definition, so I'm just abbreviating red with an R, that would be the number of ways you can get a red marble. Well, there are 6 red marbles here, divided by the total number of things that could happen. Well, there are 8 total marbles from which to pick from. So the probability of getting a red marble could be calculated with 6 over 8. If I wanted to express that as a simplified fraction, that would be 3/4. So that would be one way of expressing the probability. There's a 3/4 chance of getting a red marble. I could instead write that as a decimal by dividing. 3 divided by 4 is 0.75. So there's a 0.75 chance of getting a red marble. Or convert that to a percent by moving the decimal point or multiplying by 100%. There's a 75% chance of getting a red marble. Now these 2 numbers right next to each other, 0.75 and 75%, give me an opportunity to say something about this chapter. We're dealing with lots of percents, and they can be expressed as decimals or percents. The way you distinguish that when you look at the number is whether it has a percent symbol or not. So it's important that you show a percent symbol on your answers if you are calculating a percent. Because if you don't show the percent symbol, then it's not interpreted when somebody looks at it as a percent. So if you are writing a probability as a percent, make sure you show the percent symbol. Otherwise, it's interpreted as a decimal. That's the way we tell decimals and percents apart when we see a number written, is whether it has the percent symbol. All right, so let's use this definition to calculate a few more probabilities using a fair six-sided die. Now, we had looked at the sample space of fair six-sided die as just being the 6 options of 1, 2, 3, 4, 5, 6, just like on a Yahtzee die. Let's look at the probability of rolling a 5. Remember, with this definition, we want to ask ourselves, how many ways are there to roll a 5? Well, there's one way to roll a 5 out of 6 possible things that could happen. So 6 possible rolls or options on a die, 1 is a 5. So 1/6 is the probability of rolling a 5. Now we could instead express that as a decimal, which would be 0.1666666. Generally with decimals we round when we need to at the 3rd decimal point. Or if we wanted to make that into a percent, we would move the decimal point 2 places, so we'd get 16.7%. And with probabilities expressed as a percent, usually we round at the 1st decimal point. So as a percent, 1st decimal point rounding, as a decimal, 3rd decimal point rounding. Those are the rules that I will usually follow for worksheets or for exams. If you're using the online homework system, make sure you just follow whatever their instructions are. Sometimes they may actually ask for more decimal points listed. Part B, what is the probability of rolling a number less than 5? Well, a number less than 5 could be a 4, a 3, a 2, or a 1. So there are actually 4 options for this. So there were 4 options for getting a number less than 5 out of a total of 6 options. So 4 divided by 6. If I wanted to keep that as a fraction, I should simplify to 2/3. If I wanted to have this as a decimal, just divide and we'd get 0.666666 repeated, or 0.667. Or as a percent, that would be 66.7%. So 3 different ways you could show an answer. C, what is the probability of getting a 3 or a 5? Well, there is one 3 and there's one 5, so there's 2 ways you could get a 3 or a 5. Remember, or is inclusive, so you count both ways, either getting a 3 or getting a 5, out of 6 possible things that could happen. Simplifying that fraction, so the probability would be 1/3. So you've got a 1/3 chance of getting either a 3 or a 5. Or as a decimal, that would be 0.333. Or as a percent, that's 33.3% chance of getting either a 3 or a 5. Last question on this slide, what is the probability of rolling a 7? Well, look up here at our sample space. There is no 7, okay? So there is no way we can get a 7. We can't do it. Remember, the probability when you can't get something, or when there's absolutely no way for something to happen, is 0%. So when you realize you can't do something, that is 0. We can also, though, use this definition. There are 0 ways to get a 7 out of 6 possible outcomes. 0 divided by 6 is 0. So that's another way to kind of think about how you're getting a 0%, because you have 0 divided by 6 options.